Hi, welcome to Pre-Algebra Lesson 10-5, Solve Problems Involving Circumference of a Circle. In this lesson, we'll be able to solve problems involving radius, diameter, and circumference of circles. So let's start with exploring the concept. The distance around the circle and the distance across a circle are related. What does that mean? So let's use string to measure the distance across each circle. Do you have a string? Well, I have a mask and I have a string here. So I have a mask here and I have a nice little string here. So I'm going to use this string to measure each circle on my screen. You could find like a string anywhere. If you also have a mask, you could use that one. Or if you actually have a string, you could use that string. So let's look at each circle. So my mask, the string of my mask is very elastic. So I'm just gonna try my best to not pull this so that it changes the length. I'm just going to make sure it goes around like that without any force. I'm not gonna pull it, okay? So if you have an elastic string like me, you could also try not to pull it so that you don't change the length. Okay, let's look at each circle. We have a string, so go around the string, go around each circle like that. So using my string, it's going to be about, it's really hard not to pull it, but it's going to be, the first one is going to be about this much. Yeah, I am trying not to pull it, so I have my finger here. And then the CD would be like, ooh, CD is already as big as the string I have. Yeah, the CD would be as big as this. That could maybe stretch a little bit. So then let's look at the board, the dartboard we have. It's going to be really big. My string is not long enough for that. But if I use my mask to measure it, right, maybe it would be like about this big. Yeah. So I know it is not accurate and it doesn't have to be, and that's okay. So how many of these lengths does it take to go completely around the circle? With my string, it takes it takes less than half of my string to go around the first full circle. So it only takes less than a half of my string to go around the red button. And it almost takes as long as my string to go around the CD or the disc. It takes more than it takes longer than my string to go around the dartboard. So yeah, using my string, I would describe it like that, but using your string, it would be different. So let's look at part B. Oops, it's not labeled here, but we could just label here real quick. Use the string and the ruler to measure the distance across the circle and the distance around the circle. Complete the table, round each measurement to the nearest quarter inch. So if we use the string and a ruler, so we have a string, and if we measure it with a string and then make it flat and put it by the ruler, we can measure the distance pretty accurately, actually. So this is our goal, to measure it using our string first to go around the circle and then make it lie flat by the ruler and measure it. So using the inch ruler, you'll be able to get a pretty close approximation for the circumference of each circle. So the button around the circle would probably be about 3.2 inches, and then 3.2 or 3.3, and then the distance around the circle would probably be about an inch. And then disc, you should probably get around 6.2 inches, and then across the circle around 2 inches. Dartboard, 9.5 inches, and then about 3 inches. So if you have a centimeter ruler, write it in centimeter. If you really don't have an inch ruler, that's fine. This is just an activity for you to relate the string, how it goes around the circle, and the distance when it's when the string is made straight. So what do you notice about the ratio of the distance around the circle to the distance across the circle? So around the circle to the across, which means so 3.1 over 1, the ratio, this to this, right? So 3.2 to 1 would be a fraction 3.2 over 1. 6.2 over 2 is about 3.1, and then 9.5 divided by 3 is about 3.1 or 2, right? So they're about the same. So the ratio is about 3, and the ratio is about 3.2, 3.1, 3.2 inches. So let's look for relationships. How can you estimate the distance around any circle when given the distance across the circle? By using the string, we just did this activity, right? Or if you want to use the ratio we just figured out, we could maybe multiply the ratio 3.2 or 3.1 times your distance across the circle to get the distance around the circle, right? So we can either use the ruler, or we can either use the string as a ruler and the ruler, or use the ratio. We could use a string to measure it. Use string and ruler to measure it. Or we could use the approximate ratio of about 3.14, which is pi, by the way. So we've already figured that out a long time ago. So pi is about 3.14. You should get something like that, right? To multiply the distance around the distance across the circle to get the distance around the circle. So if you know the distance across the circle, we can use the ratio to figure out the distance around the circle. Okay, So that was a fun exploring activity. Let's look at some examples in your textbook. So example 1, describe parts of a circle and find circumference to solve problems. Mark recently replaced his front bicycle wheel. How far does the bike travel with each revolution of his new front wheel? So one revolution means one rotation. So this means one rotation, one full circle. Okay, so how many full circles would he have, right? So how much distance would one full circle go? So the diameter is 26 inches, but your distance from here, if he's biking properly, you should use the whole distance around the circle, right? To get one full circle, to go for the wheel to go around one full circle. So first of all, we need to know these terms. Remember, the radius is the distance from the center of the circle to the outside, to the outer circle, right? And then the diameter is just the distance full across the circle, and circumference is the distance around the circle. So your pi is the ratio of the circumference over distance. So your circumference could be figured out by multiplying pi with your diameter. So your diameter is 2 times the radius, right? But here we already know the diameter is 26 inches. So if we multiply that with a pi, we would get approximately 81.64. So we know that one full revolution will have Mark travel about 81.64 inches. Okay, so let's look at try question number 1. What is the circumference of the rim of a basketball hoop with a radius of 9 inches? So first multiply the radius by what to get the diameter? You have a radius, you need a diameter so that you could multiply the diameter with a pi to get the circumference, right? So radius by 2 to get the diameter because it's double radius, which is 18 inches. Then multiply the diameter by 3.4 to get a circumference for about 56.52. Okay, so there we go. If the diameter is doubled, what happens to the circumference? So if the diameter is doubled, not 18, but you double the diameter, so it's 32, then what happens to the circumference? You also double it, right? Because the circumference is pi times the diameter. So whatever diameter is, if you double diameter, so like multiply d by 2, that means you would also get times 2 for the circumference, right? Yeah. So whatever the diameter is, you multiply by pi and you get a circumference. So if you say, okay, this is really 2 times r, yeah, if you have a radius, you could break it down to 2 times r. So yes, the circumference is also double. Let me type that. So for example, let's give an example. A circle with a diameter of 2 centimeter has a circumference of about 6.28 centimeters, right? So if it doubles, then a circle with a diameter of 4 centimeter would have a circumference of about 12.56 centimeters. It's double the first circle, right? So, yep, if you try that with other examples, it always works. Let's look at the next example, example 2. Find the diameter using the circumference. Kayla and Theo got on the Ferris wheel shown. About how high will they be at the top of the Ferris wheel? So use the circumference formula to find the diameter of the Ferris wheel. We know the circumference here. So in this case, we're trying to get the diameter because about how high will they be at the top of the Ferris wheel means from here to here, right? So we're trying to figure out the diameter. So we have the equation circumference equals pi times the diameter. We already know circumference, so substitute 220 for C. And then you can divide 3.14 on both sides to get D, which is about 70. So Kayla and Theo will be about 70 feet above the ground when they're at the top of the Ferris wheel. Okay, so it's the same thing except you have a different information and you're trying to get the other variable. Let's look at example 3. Use circumference to solve a problem. The larger gear turns twice per second. It causes the smaller gear to turn. How fast does the smaller gear turn per second? So step 1, use the circumference formula to find the circumferences of the larger gear and the smaller gear. So you use the same equation here, C equals pi times diameter, and pi is about 3.14. Yes, you can use 3.14. Diameter here is 6 because this is the bigger one, and then the smaller one has a diameter of 2. You multiply them, and the circumference would be 18.84 and 6.28. And then you divide them to get the ratio. Or that also means how many smaller gear would go into the bigger gear, right? So whatever the circumference is for the bigger one, and whatever the circumference is the smaller one, you divide the bigger one by the smaller one, and you get 3. So the smaller gear makes 3 full circles for every full turn of the larger gear. Yeah, so that means this distance would go around this 1, 2, 3 times, okay, if you lay it flat. Yeah, so now you know you need 3 of the small diameter to go the circumference to go around the big circumference. But we're talking about how fast. We want to know how fast does the smaller gear turn per second. So how do we know how fast, right? You can multiply to find the number of full turns the smaller gear makes in 1 second. So the larger gear turns twice per second. And so 1 second, the larger gear turns once and twice. But then every time it turns once, the smaller gear turns 3 times as fast, right? So how many turns does it gonna turn in 2 seconds and 1 second? Because the larger one turns 2 times, you just multiply that by 2, you get 6. It's gonna turn 6 times in 1 second, right? So the smaller gear makes 6 full turns per second. So when you're talking about the speed, you need to talk about how much distance per time. Okay, you need 2 measures. Distance measure per time measure. Okay, so in this case, you can say 6 full turns, that would be the distance, per second, 1 second, that is the time. Okay, so let's look at the try question. The last try here. The circle has a circumference of 9.42 units. We already know the circumference now, right? So what's the area of this square? Ooh, this is something else now. So you're first going to figure out the circumference and then or well, you already have the circumference. First, you're going to figure out the radius, and then you know the square has two all same size. So this is, if this is r, this is the radius, that is also r. So your area of the square would be r squared, right? So figure out r and you square it. Remember, r squared is not the same as 2r, so it is not the same as the diameter. So let's pause the video, see if you can solve this by yourself. Come back when you're ready for answers. Okay, are you ready? Yeah, so I'm going to write down how we're gonna find this answer because we need to explain. So first, what do you need to do? So you divide the circumference of 9.42 units by 3.14 or pi to find a diameter of 3. Did you get that? And then because the side of the square is the radius, you can square the radius to figure out the area of the square. So diameter, the radius would be 3 divided by 2 or 1.5 units. So the area of the circle of the square is 1.5 times 1.5, right? I'm actually not going to use x. So which is 2.25 units, square units. Okay, I think that's pretty clear. So again, your final answer would be about 2.25 square units. Okay, good. I think that was the last try it. Let's look at the summary of our lesson. The parts of a circle and their relationships are summarized in a diagram below. So make sure you know what the radius is. It's the half length of the diameter, and the diameter is the distance across the circle. Circumference is the distance around the circle, and remember the ratio of the circumference to the diameter is pi. So you have the equation circumference equals pi times the diameter. Okay, so that was our lesson 10-5, solving problems involving circumference of a circle. Thanks for watching. We'll continue with the lesson in the next video. Bye!